Boring. Recap of symbol equations and an idea for balancing equations. Here we go. Firstly, the idea of an equation like this is that it gives you an awful lot of information about a chemical reaction. So if we were to take this equation here and put it into words, we would have to, well, we'd have to write a whole paragraph, because what it's telling us is that 2 moles of copper in solid state reacts with 1 mole, so you don't need the 1 there, 1 mole of oxygen molecules in the gaseous state to produce 2 moles of copper oxide in a solid state. So just with a few letters and numbers, we get an awful lot of information about a particular chemical reaction. And I'd like you, for later on, I'd like you to try and remember that these numbers tell us the number of moles of each substance that react together. So it's like giving us a ratio of the number of moles that need to react together for each particular substance. Okay, so how do we balance an equation? I've had an idea using the tokens that might help you. It might not, it's just for people who are still a little bit unsure about this bit of chemistry. So I'm going to move that board and we'll put another equation there. Okay, so we've got N2, nitrogen plus hydrogen, gives us ammonia. So N2 plus H2 gives us NH3. Now at the moment this is an unbalanced equation. We've got 2 nitrogen atoms there bonded together as a nitrogen molecule, but only 1 here. We've got 2 hydrogen atoms bonded together as a hydrogen molecule on this side, but after the chemical reaction we've got NH3. Now in a balanced equation the formulae must stay the same. However, you must also have the same number of atoms on either side of the chemical reaction. You can't create or destroy atoms in a chemical reaction. So the way that we adjust the number of atoms on each side is by adjusting the number of moles of chemicals. Now, I understand this can be a little bit tricky, so I've thought of another way that we can do this using the tokens. So let's just say for a minute that the red tokens will represent nitrogen atoms. We've got N2, so there's 2 of them. Maybe the blue tokens can represent hydrogen. There we go. And now if we build an NH3 molecule, there's 1, 2, 3. Okay, so we can see quite clearly that it's unbalanced. We've got 2 nitrogen atoms on this side, 1 here, we've got 2 hydrogen atoms on this side, and we've got 3 here. So how would we go about balancing that up? Well, the first thing is we clearly need another nitrogen on this side, but we can't just add a nitrogen atom, we have to have a whole molecule of NH3. So we put the nitrogen, but we've also got to put our 3 hydrogens there as well. So we've got another NH3. Now we've got 6 hydrogen atoms on this side, but only 2 on this side. So what we will do is keep adding hydrogen molecules until we've got the right number. There we go. So we've got 1, 2, 3, 4, 5, 6. So this is now balanced. All we need to do is add the numbers in. This is 1 mole of nitrogen, that's fine, but we've got 3 of hydrogen. 1, 2, 3. And over on this side we've got 2 NH3 molecules. So we put a 2 there. And we can see that now this is a balanced equation. 2 nitrogens, 6 hydrogens, 6 hydrogens. We'll try another one. Okay. So at first glance it looks a bit more complicated, but it's not really. Let's say blue is aluminium. Let's go for red being our bromine. Let's go for green as potassium. There we go. So we've got 1 Al, we've got 3 bromines, we've got 1 potassium here. So then we've got potassium bromide. And we've got, oh, I've done that wrong, haven't I? Potassium bromide, and we've got 1 aluminium. Again, we can see quite clearly that this is not balanced, because although we've got 1 aluminium, 1 aluminium, 1 potassium, 1 potassium, we've got 3 bromines and only 1 bromine on this side. So we have to balance that up. We cannot adjust the formula, So we have to adjust the number of moles. So if we just keep on adding potassium bromide molecules, there we go, until we've got the right number of bromines. So now I've got 1, 2, 3 and 1, 2, 3 either side of the chemical reaction. However, the potassiums are now unbalanced, so we will add in a couple more potassiums. There we go. So how many aluminium bromides have we got? Well, we've got 1, so we don't need to put a number there. How many potassiums? We've got 1, 2, 3, so we are going to put a number there. We've got 1, 2, 3 potassium bromides, so we've got a 3 there, and we've just got 1 aluminium, so we leave it as it is. As I said, you don't have to do this, so if you're comfortable with balancing equations, then that's fine. When you get your sheet, then you balance equations as you see fit. But if you think that this would be helpful, fantastic, we'll use the tokens. Okay, off you go.